to observational study versus designed experiment. Okay, we have two different situations or two different possibilities to study a population. An observational study and a designed experiment. Let's say we assume that we conduct a study about the number of packs of cigarettes that a person smokes per day and the risk of contracting lung cancer. We don't know whether the number of packs of cigarettes that a person smokes per day will imply automatically that a person gets cancer. We don't know that. But we want to study this. Here there are two variables involved at this point in time. Whether a person gets lung cancer, that's one variable. Does the person get lung cancer or not? And the number of packs that a person smokes per day is the second variable. We can discuss what type of variables they are, but right now I would like to discuss the difference between the two. When we say explanatory and when we say response, we really mean variable. When we really mean that one triggers the other. So which of the explanatory or response, you think which one will trigger the other? When we say explanatory and response. Response will be
trigger the explanatory.
Careful. The response has to have an explanation. If somebody gets a disease, normally it is explained by something. It was created by something. So the response, here's another simple example. If you ask me something, I respond. I cannot respond if you don't ask me something. That's a simple example. So I will give a response if you ask. So then which one is the one that triggers the other?
Well, I said response because you said the response is the number of packs per day, right?
No, very good.
Oh, that's what I thought you said.
Good. No. I said we want to see if a person gets lung cancer based on how many packs of cigarettes that a person smokes per day. So the explanatory variable will be what the person is doing. The response, the result, may be, not necessarily, but may be the lung cancer. Does it make sense? So let's put it in writing. The explanatory variable, in this case, is the number of packs of cigarettes. This is what explains, we hope, that this is the variable that explains the response. The response variable is whether the person contracts lung cancer or not. Contracting lung cancer or not. Any questions? So the response depends on what I do. I may break my leg if I play, I don't know what, tennis. So that's the explanation. I broke my leg, which I did when I was climbing some trees when I was a kid. So I climbed the trees. That's the explanation. And the response was, I broke my foot. Somebody smoked several packs of cigarettes per day. And the response was, the person got cancer, lung cancer. Very good.
The response is really a result.
Exactly. It's like I'm responding to your question. You have a question? That's my response. Very good. Does it make sense?
Yes.
Okay. So now let's try to fill in the important, the missing words here, which are the key words, the important words here. We want to determine how varying the amount of effect.
Cigarettes.
Yes, exactly. Which variable?
Cigarettes is the explanatory.
Very good. The explanatory variable. Excellent. Affects the value of which variable?
Response.
Excellent. Okay, and as I mentioned, we have two options here. We have an observational study and a designed experiment. I will explain what they mean, and then we'll look at an example. Okay, so let's continue with what an observational study is, and then a designed experiment. Observational study. And what it does, it measures the value of the response of course, the response variable, without influencing the value of the variables in general, without any influence, without any intervention, in short, of any kind, no intervention. Just observe. No intervention, no separating the sample in different groups, nothing of that kind. No intervention of any kind. Just observe. What is a designed experiment? A designed experiment requires a lot of work, a lot of thinking. First of all, the researcher assigns individuals in groups. He or she may apply a treatment. This is a key word. To one group or another. What does that mean? So, for example, we have, let's say, the COVID vaccine. It's not available yet. They haven't finished the studies yet, I don't think. But let's suppose we're talking about the COVID vaccine. The researcher may separate individuals into two groups. This group, let's say, they are taking the vaccine. And this group, we are not giving them the vaccine. We're just giving them placebo. Just water. We tell both of both groups, we are giving you the vaccine. We are not trying to lie to them, but we need to study, and we don't want to tell them it's a blind study. Sometimes the researcher, to avoid bias, the researcher is not told which group. He separates them into two groups, but he himself may not know which group is getting the vaccine and which group is not getting the vaccine. We are not damaging them or harming them in any way by giving them water. So the researcher separates the two groups, and at the same time may apply a treatment to one group and not to the other in order to study the behavior and what happens next. If the vaccine, sometimes, and it's very well known, people from both groups think that they are getting the vaccine, and even these, some of them perform as if they were getting the vaccine. So there is a lot of thought and input in there. What else the researcher does in the design experiment? He records. He or she records the results. So number one, he assigns groups the individuals in groups. Number two, the researcher may apply a treatment. By treatment, we mean we are giving the vaccine to a group, and another treatment is the placebo to the other group. This is called treatment. And also the researcher records the results. So what are the differences here between observational study and design experiment? A design experiment is a well-thought process. You can say, what about the observational study? Is that a well-thought process? Yes. But the researcher cannot do anything other than observe. Here, the researcher has a lot of work. Doctors, mathematicians, depending on the study, it may not be on a health issue. So a lot of people are involved here. An observational study, everyone can conduct. You don't have to be a highly qualified statistician or highly qualified doctor, etc., etc. Here, this is a different story. Okay, so now let's finally look at an example. And I like to entitle this, You Decide. So which one is a design experiment? Which one is an observational study? Circle the correct answer. So let's read this. 878 students in U.S. universities were surveyed to determine their opinion on online versus face-to-face classes. The result, the students prefer the online classes. Do you think that this is a well-thought, well-designed experiment in which the researcher separates students, records their progress, maybe gives them a treatment, etc., etc., or an observational study?
Observational.
Very good, awesome. A total of 85 students were asked to use toothpaste. Always stop me if you have questions, please. I don't want to say that all the time. I know it's repetitive. So you always unmute yourselves and stop me if you have questions. To use toothpaste with fluoride, and 85 were given toothpaste without fluoride in order to study the effect of fluoride on their teeth, enamel, cavity, etc. What do you think? This is just an observational study or a treatment? So-called treatment was applied. They were separated in groups and the results were recorded after a while. I'm sure you said something, but I was talking at the same time. I'll shut up.
The design experiment.
Very good. Moving on. Great job. Okay. The next topic, number 5, is about confounding. Let's see what that means. Confounding is it can occur in a study when this study that we talked about at the very beginning, this one, had one explanatory variable and one response variable. There is no possibility of confounding here. But if we have more than one explanatory variable, then confounding is possible. So is possible when 2 or more explanatory variables exist. So if I go back for a moment to the study with packs of cigarettes and cancer, we only analyze explanatory variable here as being the number of packs of cigarettes. But who knows? Maybe they have health issues. Maybe age is a problem. Of course, if in the study, if we're talking about a person who is 105 years old or a person who is 30 years old, yes, a person with 105 years old, who's 105 years old, of course that person may have more health issues. Age may be a confounding factor or variable. So these are possibilities, but when we are discussing two or more explanatory variables. So, in other words, what is a confounding variable?
Is a confounding variable a variable that's not being studied but may affect the result?
Well, the answer is that it is studied. A lurking variable is not studied. So the confounding variables cannot be separated. That's the problem. I cannot separate somebody's age from his habit of smoking. So the habit of smoking X number of cigarettes or packs per day and the age are confounding variables. I cannot separate them. I study them both because I may separate the sample by age. So I can study. So the confounding variables just cannot be separated, but they are studied. So the relationship that may exist between the explanatory and the response variable can be due to some other variable, not accounted for. Now, moving on to the what is called the lurking variable, that we are not studying. It can be age, it can be health issues, but we are not studying it. So it's a explanatory variable that is not considered in the study. So it's also an explanatory. Not studied in the whatever observational or designed experiment. So examples of a confounding variable we already have, like age and habit of smoking. The example of a lurking variable could be age. Again, we could be health status, or depending on the age of the individuals, it can be other things. So item 9. Put this aside. Item 9. An observational study does not allow a researcher to claim, the observational study cannot claim cause. It cannot claim cause. So in other words, if we conduct a observational study on the number of packets of cigarettes per day, smoked per day, and the lung cancer, and if it's an observational study, we cannot say that the number of packs smoked, number of packs of cigarettes smoked per day, you understand that, causes lung cancer. We cannot say that. We can only say that it's associated. Yes, please? Any questions? I thought somebody had a question, sorry. So,
I would just ask, say associated?
Yes, so we can say association, but we cannot say causation.
Okay.
So we can say that if we conduct an observational study, we can say that there is an association. It appears from our study that the number of packs of cigarettes smoked per day is associated with lung cancer. But we cannot say that the number of packs of cigarettes smoked per day will cause lung cancer, because it's only an observational study. Item number 10. How can we tell the difference between an observational study and a design experiment? I think that this is very clear. What do we say? How can we tell the difference between an observational study and a designed experiment?
The design experience